Hello everyone. In this video we are going to discuss about the effect of change in rotor resistance as well as rotor reactance on torque of a three-phase induction motor. Okay. So first we'll write the torque equation. So the general torque equation is directly proportional to S into E2 square R2 divided by R2 square plus SX2 whole square. Okay. Suppose if we increase the rotor resistance, if we change the rotor resistance, the torque also changes. Okay. Similarly, the starting torque of the motor is given by, in the case of starting, S is equal to 1. Okay, S will be equal to 1. So this can be written as E2 square R2 divided by R2 square plus X2 square. Okay. So here also again, as the rotor increases, the starting torque increases. Okay. So next we'll write down the torque corresponding to maximum value, that is maximum torque. So in this case, the maximum torque is given by S suffix m. So S suffix m is nothing but the slip corresponding to maximum torque, E2 square R2 divided by R2 square plus Sm x2 whole square. So here Sm is nothing but R2 divided by x2 as we all know. So if we substitute for Sm here, R2 divided by x2 into E2 square into R2 divided by R2 square plus R2 by x2 into x2 whole square. So x2 will get cancelled. So in the numerator we will be having R2 square E2 square divided by x2 whole divided by 2 into R2 square. So this R2 square will get cancelled. So the maximum torque will be given by E2 square divided by 2 into x2. So this maximum torque is independent of the rotor resistance, whereas the slip corresponding to maximum torque depends on the rotor resistance. So if the rotor resistance value is increased, the slip corresponding to maximum torque will increase, whereas the maximum torque will remain constant. So if you see the torque slip characteristics, by taking slip along the x direction and torque along the y direction. So here slip starts at S is equal to 0 and S is equal to 1. Okay, S is equal to 1 corresponds to the starting torque value. Okay, starting condition. So already we have discussed this torque slip characteristics. When slip is 0, torque will also be 0. As the slip is increased, the torque also increases and attains its maximum value. So after reaching the maximum value, okay, till the maximum value is reached, it will be linear. So after maximum value, it will be rectangular hyperbola. Okay, this is the starting torque. So on the slip corresponding to the maximum torque will be given by S suffix m. Okay, so this is for the rotor resistance value of R2. Okay, suppose the R2 is increased from R2 to R2 dash. We are adding some external resistance to this R2. So if we add our external resistance, say Rex, then it will become R2 dash. This R2 has been increased to R2 dash. In such case, what will happen? The starting torque also increases. Again, the slip corresponding to maximum torque also increases, whereas the maximum torque will remain the same. So we'll get the curve parallel to this curve with the same value of maximum torque, but the slip corresponding to this maximum torque will be changed to Sm dash, and again the starting torque will get increased from TST to TST dash. So this is nothing but R2 torque corresponds to R2 dash. If we further increase this R2 dash to R2 double dash, again this curve will be parallel. Okay, and the slip will become Sm double dash, that is the slip corresponding to maximum torque, and the starting torque will become S2 double dash. So these are the changes that will occur in the torque slip characteristics when resistance value is changed. Suppose if we change the reactance value, okay, so if we change the reactance value, if you see here, the reactance is present in the denominator. So if we increase the resistance, the starting torque will decrease, and again if we increase the resistance value, reactance value, this slip, if x2 is increased, the slip corresponding to maximum torque decreases. Okay. Similarly, the magnitude of this maximum torque also decreases. As x2 increases, the maximum torque also decreases. So with the increase in x2, maximum torque decreases, slip decreases, as well as the starting torque also decreases. So if we draw this torque slip characteristics again, here S is equal to 1, here S is equal to 0. So for normal condition, for the normal Z2 X2 value, we'll be getting this torque slip characteristics. Okay. So this is the slip corresponding to maximum value SM, and this is the starting torque. Okay. And this will be the maximum torque value for the rotor resistance R2. Suppose if the rotor resistance is this is rotor reactance, right? So for the normal rotor reactance value, if the rotor reactance is changed, so then the maximum torque also decreases. If we increase this value, this torque will decrease, and again the slip corresponding to this reactance value also decreases. Okay, and similarly the starting torque also decreases. So now we can draw another curve in which the slip corresponding to maximum torque decreases, maximum torque value also gets decreased. So let this be Tm dash, and the slip corresponding to this torque is Sm dash, and this is Tst dash. Okay, so this is the value corresponding to x2 dash. So if we further decrease it, everything will get decreased. Okay, so this maximum torque will get decreased to Tm double dash, and the slip corresponding to maximum torque will decrease to Sm double dash, and starting torque also will get decreased to Tst double dash. Okay, so if the rotor resistance value is increased, the maximum torque will remain unchanged. Okay, whereas the slip corresponding to maximum torque will increase. Similarly, the starting torque also increases. Whereas in the case of reactance, if we increase the reactance, everything will get decreased. That is, the slip corresponding to maximum torque decreases, maximum torque also decreases, and similarly the starting torque also decreases. So next we'll solve the numerical. Here the question is, a 6-pole 50 Hz 3-phase induction motor has a rotor resistance of 0.25 ohm per phase and a maximum torque of 10 meter at 875 rpm. Okay, so the maximum torque is given 10 Newton meter. The speed corresponding to maximum torque is also given 875 rpm, and the motor specifications are 6-pole 50 Hz 3-phase, and the rotor resistance is given R2. Okay, so now we have to calculate the torque when the slip is 5%. So we have to calculate the torque corresponding to 5% slip. And second one, the rotor resistance to be added in the rotor circuit to obtain 60% of the maximum torque at starting. Okay, next second one is we have to find out the rotor resistance value to be added to the circuit in order to increase the starting torque to a value of 60% as of the maximum torque. Okay, so first we will solve one by one. First we'll write the given data. So we have number of poles P is equal to 6, frequency F is equal to 50 Hertz, and a rotor resistance at standstill condition, that is R2 is 0.25 ohms per phase value. So this is per phase value, and the maximum torque is given. So maximum torque value is 10 Newton meter, and the speed corresponding to maximum torque represented as N suffix M. Okay, this is a speed corresponding to maximum torque 875 rpm. Okay, so first thing what we have to find out is the torque when the slip is 5%. So let this be T1. Okay, this torque will be T1 and slip will be 5%. 5% means 5 by 100 is equal to 0.05. Okay, so now we will have to find out the value of T1. Okay, so we have already derived the torque ratios. Okay, So now we'll write the formula for T1. So T1 is equal to S1 into R2. So here S1 is the slip corresponding to the start T1, E2 square divided by R2 square plus Sx2 whole square. So here S corresponds to S1 value. Okay. Similarly, we can write the maximum torque as S suffix m. So this is a slip corresponding to maximum torque, okay, into R2 into E2 square divided by R2 square plus Sm into X2 whole square. Okay. So now here we have S2, S1, R2. Okay. But here we do not have this Sm as well as X2. So we have to find out this Sm value as well as this X2 value before solving this problem. Now, first we will find the synchronous speed Ns. Synchronous speed Ns is equal to 120 F by P. So 120 into 50 divided by 6. So on solving this, we will get 1000 RPM. Okay. So now we are given with the speed corresponding to the maximum torque 875. So from this speed, we can find out the slip corresponding to maximum torque as Ns minus Nm divided by Ns. So Ns is nothing but 1000, Nm is 875. So divided by 1000, we'll get 0.125 as the slip corresponding to maximum torque. Okay. So now we know that the slip corresponding to maximum torque can be written as R2 divided by X2. Okay, from this expression we can find out X2 as R2 divided by Sm. So R2 is nothing but 0.25, Sm is nothing but 0.125. So on simplifying these two, we will get 2 ohms per phase. So X2 is 2 ohms per phase. So now we have got all the values corresponding to this torque equation, that is Sm X2. Okay. So now we will find out the ratio of T1 and Tm and find out this T1. Okay. So next we will write the ratio between T1 and Tm. Okay. T1 by Tm is equal to, T1 equation is S1 into R2 into E2 square divided by R2 square plus S1 X2 whole square. Okay. So this entire thing divided by Tm value. So Tm equation. So Tm equation is something but Sm into R2 into E2 square divided by R2 square plus Sm into X2 whole square. Okay. So now we can keep the numerator as such. S1 R2 E2 square divided by R2 square plus S1 X2 whole square, and this term can be multiplied by the reciprocal. So if we multiply with the reciprocal, then we'll get R2 square plus Sm into X2 whole square divided by Sm into R2 into E2 square. Okay. So this R2 and E2 square terms will get cancelled. So in the remaining terms we have S1 into R2 square plus Sm X2 whole square divided by Sm into R2 square plus S1 X2 whole square. Okay. So now the maximum torque value is given as 10 Newton meter. So we will substitute 10 here and substitute all the required values. So S1 value we all know 5%. So 0.05. So multiplied by R2 value is given. R2 value is 0.25. So 0.25 square plus Sm we have found out 0.125. So 0.125 into X2 is 2 whole square. Okay, this is the numerator. So the numerator divided by the denominator. In the denominator we have Sm value. Sm value is nothing but 0.125. So multiplied by R2 square. R2 square is again 0.25 square plus S1 into X2 whole square. So S1 is given 0.05 into x2 is 2 whole square. Okay, so on simplification we will get 0.05 multiplied by 0.0625 plus 0.0625 whole divided by 0.125 multiplied by 0.0625 plus 0.01. Okay, so on simplification, on further simplification, we will get this value as 0.689655. So on the left hand side we have T1 by 10. So now T1 can be found out by cross multiplying 0.689655 multiplied by 10. This will be equal to 6.89655 Newton meter. So this is the required answer. So now we will solve the second subdivision. In the second subdivision, it is given that the resistance to be added to the rotor circuit. We have to find out the resistance to be added to the rotor circuit. Let us consider R2 dash is the increased value of rotor resistance, which is nothing but R2 plus externally added resistance value. Okay. So to obtain 60% of the maximum torque at starting. So as the resistance is increased, starting torque also increases. So which is equal to 60% of the maximum torque. 60% is nothing but 60 by 100.6. So it can be written as TST dash divided by TM is equal to 0.6. Okay. So now we'll write the equation for TST dash and TM and substitute the corresponding values. So TST dash can be written as at the starting S is equal to 1. So R2 dash into E2 square divided by R2 dash square plus X2 square. Okay. So next TM can be written as R2 into SM into E2 square divided by R2 square plus SM into X2 whole square. Okay. So now we'll divide these two equations, TST dash divided by TM. So this is equal to R2 dash into E2 square divided by R2 dash square plus X2 square. Okay. So divided by TM. So if we want to divide this by TM, we can then multiply this whole term with the reciprocal. So multiplying with the reciprocal, we'll get R2 square plus SM into X2 whole square divided by R2 into SM into E2 square. So this E2 square term will get cancelled. So the remaining terms will be R2 dash multiplied by R2 square plus SM X2 whole square. Okay. In the denominator we have R2 into SM multiplied by R2 dash square plus X2 square. So this is equal to 0.6. Okay. So now we have to find out the resistance value Rex. Okay. So first we'll find out R2 dash value. So here in the numerator, the R2 dash value is the unknown value. So we'll keep it as such. And here we'll substitute the value of R2, which is 0.25 square plus SM value already we have found out 0.125 and X2 value also we have found out to be 2, so whole square. Okay, this is the numerator term. So divided by the denominator we have R2 into SM multiplied by this term. So R2 value is again 0.25 and then SM value is 0.125 multiplied by R2 dash square is the unknown value and X2 square is 2. So this will be equal to 0.6. So on simplification, we'll get 0.125 R2 dash divided by 0.03125 into R2 dash square plus 0.125. So this will be equal to 0.6. So now we will cross multiply. So on cross multiplication, we'll get 0.125 R2 dash. This will be equal to, so we can multiply this 0.6 with the denominator term. So on multiplying this, we will get 0.01875 into R2 dash square plus 0.075. So on rearranging this equation, we'll get 0.01875 R2 dash square minus 0.125 R2 dash plus 0.075 equal to 0. So this is a quadratic equation in R2 dash. On solving this equation, we will get R2 dash as 0.6666 ohm. So now we have to find out the REX value. So we know that R2 dash is equal to R2 plus REX. So from this we can write REX is equal to R2 dash minus R2, which is nothing but 0.666 minus 0.25. Okay. On simplification, we will get 0.4166 ohms. So this is the external resistance value to be added in the rotor circuit to obtain 60% of the maximum torque at starting. Now we'll continue with the second problem. In the second problem, the question is an 8-pole 50 hertz 3-phase induction motor is running at 4% slip when delivering full load torque. Okay. It has standstill rotor resistance of 0.1 ohm and reactance of 0.6 ohm per phase. Okay, both are per phase values. Calculate the speed of the motor if an additional resistance of 0.5 ohm per phase is inserted into the rotor circuit. Assume the full load torque remains constant. This is a condition given. In both the cases, the torque will remain the same. Okay. So what we have to find out is we have to calculate the speed of the motor if we add some resistance, additional resistance to the rotor circuit. Okay. So for that, first we will write the given data. So now the given data is number of poles P is equal to 8, frequency F is equal to 50 hertz, and then this is a slip corresponding to 4%. That is, this is a slip corresponding to the normal value of the rotor resistance when additional resistance is not added. So 4% means 4 by 100, 0.04. And then it has a rotor resistance R2 dash under normal conditions 0.1 ohm per phase. And similarly, rotor reactance is also given 0.6 ohm per phase. Okay. So now we will have to calculate the speed. Okay. Let this be the speed N dash, because we have added the additional resistance. So we have to find out the speed after adding the resistance value. Now this additional resistance, so let REX be the additional resistance, which is given by 0.5 ohms per phase. Okay. So now we will have to find out R2 dash. R2 dash is the increased value of rotor resistance. So that is R2 plus REX. So R2 is given as 0.1. Now the additional resistance is 0.5. So the total is 0.6 ohms per phase. Okay. Now the condition given is in both the cases torque remains the same. That is, suppose if we take T1 as the torque in first case and T2 as the torque in second case, then this will be same, or T1 by T2. T1 by T2 will be equal to 1. So now we'll write the formula for T1. T1 is nothing but the torque corresponding to the normal rotor resistance value. So in that case, slip is S into R2 into E2 square divided by R2 square plus SX2 whole square. Okay. Similarly, in the second case, we have added the additional resistance. So the slip becomes S dash, resistance becomes R2 dash, E2 square will remain the same, divided by R2 dash square plus S dash into X2 whole square. Okay. So now we will divide these two, that is T1 by T2. So T1 is S into R2 into E2 square divided by R2 square plus Sx2 whole square. So if we divide this by T1, then we can multiply them with the reciprocal of T2. Okay. If we divide this equation by T2. Okay. So we can multiply them with the reciprocal. Here the reciprocal will be, the denominator will go to the numerator. R2 dash whole square plus S dash X2 whole square divided by S dash R2 dash into E2 square. So E2 square will get cancelled. So now the unknown value is S dash and S dash only, because we have the R2 dash value. So we will find out the S dash value. So once we have found out the S dash value, we can easily find out the N dash. Okay. So now we will, so this ratio T1 by T2 will be equal to 1 as it is given. Okay. So now we'll substitute all the given values. So in the numerator we have S into R2 multiplied by R2 dash square plus S dash into X2 whole square. Okay. In the denominator we have S dash into R2 dash multiplied by R2 square plus Sx2 whole square. So now we'll substitute all the values one by one. S will be equal to 0.04 into R2 value is 0.1. Okay. So this term is multiplied by R2 dash square, that is R2 dash square is nothing but 0.6 square plus X2 is 0.6. S dash we have to find out whole square. Okay. So divided by the numerator we have S dash and R2 dash. Again R2 dash is a known value 0.6. S dash we have to find out. So multiplied by R2 dash, R2 square. Here R2 square. So this is nothing but 0.1 square plus S into X2. So S is 0.04 into X2 value is 0.6 whole square. This will be equal to 1. So now we can cross multiply this equation. So on cross multiplication we will get 0.04 into 0.1 multiplied by 0.6 square. We will keep them as such. S dash whole square, that will be equal to 0.6 S dash multiplied by 0.1 square plus 0.04 into 0.6 whole square. Okay. So now on simplification we will get the quadratic equation in S dash. So this equation will be 0.36 S dash square minus 1.5864 S dash plus 0.36 will be equal to 0. So on solving this equation, we will get the S dash as 0.24. Okay. So this is a slip, so 0.24. So this is the slip corresponding to the additional resistance. Okay. After adding the additional resistance. So now we will have to find out the N dash. So for that N dash formula can be written as N dash is equal to Ns into 1 minus S dash. So first we have to find out Ns, synchronous speed, 120 by P. So 120 into 50 divided by number of poles is 8. So this will be equal to 750 RPM. So now we'll substitute in N dash equation 750 multiplied by 1 minus 0.24. So on simplification we will get 570 RPM. So this is the answer. So now if you add the additional value of rotor resistance, the speed will decrease.